Hello my dear friend. So welcome to this video where we are going to learn HCF and LCM. You might be aware of what is LCM and HCF. Today we are going to learn a new way of finding the HCF as well as LCM. Before we go to that method, let us properly understand. You might have understood it in a different way. We are here understanding to get into the depth of the concept, and we should be able to apply it wherever it is required properly. If you have the in-depth knowledge about HCF and LCM, you will be able to find the HCF LCM much faster. So what is HCF? So HCF is also called as GCD. GCD means greatest common divisor. So factor is also divisor, which we have already seen. So this is also called as divisor. So the number which divides any number is also called a factor. So what I am going to do is I am going to bracket into these three components and make the understanding very clear. Say for example, I'll take a number. I'll take a number of as 12. So 12. What are the factors of the 12? Factors means what? The numbers which divide the given number. Any factor is a number which can divide the other number, which we have already known. So what are the numbers that can divide 12? So 12 can be divided by 2, it can be divided by 3, it can be divided by 4, and it can be divided by 6. We'll leave aside the number and 1 which are not required. Then we want common. If I want common, I need another number. So I am going to take 16 as the another number. So 16, is it divisible by 2? Yes, it is divisible by 2. Is it divisible by 3? No. Is it divisible by 4? Yes. Is it divisible by 6? Not possible. So it is divisible by 8 as well. So these are the three numbers which are the factors of 16, and these are the factors of 12. 2, 3, 4, 6 are the factors of 12. 2, 4 and 8 are the factors of 16. What are common here? So we'll find out the common ones. 2 is common and 4 is common. There are two factors which are common. So common ones, if I ask among 12 and 16, among 12 and 16, it will be what? 2 and 4. Now which one is the highest? See here, when we find the common, we will find the highest one as well. 4 is the highest. So this is your HCF or GCD. So any two number or more than two numbers as well, if you want to find out the HCF, we have to first find out the factors. We have to find out what are common in it, and then we have to find out which one is the highest among the common factors. So that is your answer. So your answer is 4 here. Is that clear? Okay. So how do we find the HCF now? There is prime factor method. So first we'll take prime factor method. So 12 and 16. We'll go with the smaller number so that the understanding is clear, and thereafter we are going to solve some of the questions which have appeared in the previous examination. So prime factor method, what we'll do is we will find the prime factors in it. What are the prime factors which make up 12? So how do I find the factors? So I am going to teach you also how to find the factors of any number, and this is very important skill you need to learn. So 12, if I want to find the factors of 12, this is a simple number still. What I'll do is I'll first try to divide it by 2. If I divide it by 2, what I'll get? 2 and 6. So 2 into 6 is 12. But this is not a prime number now. This is not a prime number. So again I have to divide this. This is divisible. So 2 and 3. So again 2 and 3 will get me 6. But if I want to get 12, I need to multiply 12. So these are the prime factors of 12. So 2 into 2 into 3. So this is the skill with which we will be using for a quick method as well. So what is 16 then? 16 I am going to do the same way. 16 prime factor it. So divided by 2, what I will get is 8. Again divide it by 2, I'll get 2 and 4, and 4 is also divisible again, so 2 into 2. So what will come here? 2 into 2 into 2 into 2. 2 into 2 into 2 into 2. So these are the prime factors. Prime factor method, what we'll do is we'll first find out the prime factors. Once we find the prime factors, then what we'll do, we'll find what are common here. Common here. What is common here? 2 into 2 is here and 2 into 2 is here. So this is the extra in 12 and these are the extra in what? 16. So whatever is the common ones, we will multiply them. So 2 into 2 is common. So we'll take 2 into 2, which is equal to 4. So 4 is your HCF. This is how we'll find. We'll first find out the prime factors, and among them we'll find out the common ones. The common ones only once we'll multiply and we get the HCF. This is prime factor methods, my dear. This is prime factor method. So I think it is clear, very clear. And with this only we are going to use find quick method as well. So let us remove all the ink here. Then we will go to division method. How do we do with the division method? So division method I am going to show you. So this is the division method. One more method is the long division method, that I am not now telling you. I am telling you the division method, 12 and 16. So in division method, what I will do is first I will find out what is the number common in this which can divide these numbers, which is the common number which can divide it. So that is 2 now. So 2 6s are 2 8s are. Now can any number divide both the numbers? So we can again 2, we can take 3 and this will be 4. Now there is no common number except 1 which can divide 3 and 4. Which can divide 3 and 4. Both methods look like same only, but again it depends on how you look at it. So this is again what we will do. You will see what is the common here, and then we'll divide it with the common factor here. Again common factor, we'll go on doing it till the common factor is there. Once common factor is not there, we'll leave it. We'll leave it and only multiply these two. 2 into 2 again will be 4. So that is clear, I think. That is clear now, right? Now we'll come to the quick method. So what is the quick method? Try to, before we go to the quick method, we need to understand one concept. The concept says that what is an HCF? What is an HCF? We'll try to understand what is an HCF. HCF is the number which divides more than one number. It is the biggest number which divide any given numbers. For example, in this 12 and 16, 4 is the number which divide this also perfectly and this also perfectly, and this is the highest among those numbers which can do this. Is that clear? HCF is the number which can divide both the numbers or more than two numbers as well, and among them which can divide these numbers, this is the highest number. That is what we found out in the previous slide. Now when this number can divide both the numbers and 4 can divide both the numbers, then these two numbers should come in the table of 4. Yes or no? When 4 can divide 12 and 16, any number which can divide other numbers, so those are its multiples, or it comes in the table of that number. Again, we'll take one more example like 35 and 45. 35 and 45. What is the HCF? HCF is 5 here, my dear friend. So 5. So 5 can divide 35, 5 can divide 45. So what does it mean? It means that these two numbers will come in the table of 5. So if any number come in the table of 5, what will be the minimum difference between any two numbers? What will be the minimum difference between any two numbers? That will be the HCF. The HCF can only be the minimum difference between two numbers. Is that clear now? right? See here, 12 and 16. That is the difference between these two, and that can be the HCF. It can be either the difference. Listen carefully. The HCF of any two numbers can be the difference of those two numbers or the factor of that difference. And right here, HCF can be the difference between given numbers or its means was the difference or its factor So we'll see the both the cases here. What is the difference between these two? That is 4. 4 can divide both of them, then that is HCF. In this case, what will happen? What is the difference here? Difference between these two? 10. 10 cannot divide 35 or 45. So what I'll do? I'll find its factors, 5 and 2. Now we'll see 2 cannot divide it because these are odd numbers. So 5, can it divide both of them? Then they can divide. Even in this case, say for example, I'll take 22 and 27. Now what I'll do, I'll see please listen to it carefully and try to understand. What is the 5 here? 5 cannot divide 22 or 27. Then what will happen? What are the factors? 5 and 1, because it's the prime factor, prime number. So 5 and 1, then it can be divisible by only 1. Only 1. Is that clear? So if it cannot be divisible by the factors other than 1, then 1 will be the answer for the HCF. Is that clear? So I'll do one or two more questions so that it will be easier for you to understand. So quick method, I'm going to do one or two more. I will take, say for example, 36 and 46. Okay, 36 and 46. So what is the difference? Quick method I'm telling you. First, what I'll do, I'll find the difference. Difference is 10. 10 cannot divide this. Then I'll find out the factors of it. Factors are what? 5 and 2. 5 can divide, not possible. 2 can divide, yes, 2 can divide this. So 2 is the HCF of these two. One more number we'll take, say for example, 49 and 84. 49 and 84. So we'll try to find the difference between these two. Quick method this is. So what is the difference? Difference is 35. So 35 can it divide? Not possible. So what are the factors of it? Factors are 7 and 5. Now can 5 divide? Not possible. Then can 7 divide? 7 I'll see 7. 7 is 49. 7 on the 7. 7 to the 14. So 7 is the HCF. Is that clear? Very, very simple. Find the difference. See if the difference can divide those two numbers. Listen carefully. Find the difference between two numbers and then find whether that number can divide both the numbers. If it cannot divide, then find its factors. Find the factors of difference and see if the factors of that difference can divide those two numbers. If any of the factor can divide it, well and good, that is your HCF. If none of the factors can divide it, then 1 is your answer. You can note down properly so that this will be your method now onwards. Even I am going to show you how we use this for 3 or 4 numbers when the question comes. Now try to understand only the method. So that makes it. And if you want to know the long division method, some of you are interested to know long division method, that also I am going to show you long division method, which I have not written it, but we can do it. What is the long division method? Only for 2 it is very useful. Say for example, I have to find out the HCF of this. So 46, what I'll do, 46 I will divide it by 36, not with the common factors like division method, long division method this is. So what I'll do, I'll divide it by 36. 36 ones are 36. What is the remainder? Remainder is 10. Now what I'll do, please see carefully. I will divide this divisor with the remainder. I will divide the divisor of these two. The smaller one will be dividing the bigger one, and this divisor I will divide by the remainder. So 10 threes are 30. What is the remainder now? 6. Is it clear? 6. So what I'll do, I will divide 10. Again I'll take the divisor of the previous one and divide it by 6. So when I divide it by 6, 6 on the 6. So what will remain? 4. Again I'll do it here. 4. I will make the divisor and I will divide 6 with 4. 6 with 4, 4 on the 4. So what will remain here? 2. Now I will take this as dividend and divide it by 2. 2 to the 4. So you get a 0. Okay, this is long, therefore it is called long division method. Can you see here? To get this, we would have got it within 2-3 seconds. But now with the long division method, it is taking so much of time. So what is this? 0. Is that clear? So whichever makes the remainder 0 is your HCF. For big numbers this is good. For big numbers this is good, but we are trying to use only the quick method every time. Quick method. Very quick. So same way we are going to learn what is LCM now. LCM is this. So LCM is least common multiple. It is not multiples, it is least common multiple. We are going to find out the multiples, therefore I have written as multiples. So I am again going to take this 12 and 16 so that our understanding becomes clearer with only one example. So what are the multiples of 12 now? I am going to write one below the other so that it will be easier to understand now. Multiples of those numbers which are divisible by the given number. So multiples are those numbers which are divisible by the given number. So what are those numbers which are divisible by 12? 12, 24, 36, 48, 60, 72, 84, 96, and you know there is no end. There is no end to it. So I will go to the 16, 16, 32, 48, 64, 80, 96, and so on, 102 I think, and so on up to infinity. So these are the multiples of 12 and 16. So what are common here? We'll try to find out common. What are common here? 36 is not common, 24 is not common, 48 is common. 48 is common. Then try to understand, once you get the common one, the next common will be multiple of this. Just observe. There cannot be anything else. 48 to the 96, only 96 can be common here now. That is what it is. LCM is all about. So I'll just tell you. So 48, 96. If you want, it can be odd. 48, 96, then 192, and so on. So numbers will be, lot of numbers will be common here. I left the in between, whatever it is. So that is fine. So now what is least here? Least is 48. Least is 48. So 48 is your LCM of 12 and 16. That is understood. So you have to find the multiples, then the common ones, and out of that least. I used to tell in the class, see, why we take least common multiple? Because we cannot find the highest common multiple. It's highly impossible. It's impossible because it's infinity, my dear friend. I do not know that now. Multiples can be infinity, so the highest common multiple can be anything. We cannot even comprehend. And why do we calculate the HCF? HCF because if we try to find out LCF, that is the least common factor, then it will be 1 always. So what is the point? So therefore, they are asked us to do this way, I think. But jokes apart, there are several applications, actual day-to-day applications as well. So now again we'll go to finding the HCF and LCM. So how do you find? So prime factor method I am going to teach you again 12 and 16. Again we'll see that 2 into 2 into 3 is the prime factor. Here it is 2 into 2 into 2 into 2, which we have already found. What is the difference between in HCF and LCM is, in HCF we'll take only the common ones. Common ones is 2 into 2 and then multiply them. Means we'll take only 2 into 2 as the HCF. But here what we'll do, we'll take this common apart. Common we'll take apart, 2 into 2 and 2 into 2, and we'll multiply the remaining ones. Remaining ones is 3 into 2 into 2. So this is your LCM. This is your LCM. 2 into 2, 4, 4 into 3 is 12, 12 into 2 is 24, 24 into 2 is 40. And this is how we'll do with the prime factor method. Common ones we'll take only once. Uncommon ones we'll multiply with the common ones. Is that clear? Common ones we'll take only once, and uncommon ones we are going to multiply one more time. So that is prime factor method, my dear friend. Now we are going to go for next method, which is called division method. Again, division method will be same what we did. So 12 will take, 16 will take. Okay, so first we'll divide by 2. 2 6 are 2 8 are, again we'll take 2. 2 3 are 2 4 are, again what we'll do now, this is the HCF, right? This is the HCF, right? So now to find out LCM, we'll not leave here, we'll continue and we'll see that even if any number can divide even one number, we are going to use it, right? So what we'll do is, we'll take here 3. What will divide again? 2 will divide this one. The remaining will write as it is. Will not touch it. And then again we have to leave it here. So you need not, because once you find that these are prime numbers, leave it. You can multiply them directly. You have to multiply all of them. These two below, which are prime numbers, till you get the prime numbers, you have to continue. 2 into 3 into 2 into 2 into 2, which is equal to 48, we have already found. So these two methods are only for your knowledge sake. Actual what we will take is this quick method. So quick method, again we'll try to understand the concept now. We'll try to understand the concept and then we'll solve it. See, if I take these two numbers, then what can be LCM? Just think on it. It cannot be anything less than this 16. Can it be anything less than this 16? Because what we are going to find out is the number which is divisible by both of them. The number which is divisible by both of them, it should be divisible by this number as well as this number. So it cannot be less than 16. It can be minimum the greater number, or try to understand, it should be multiple of that greater number, because it has to be divisible by that number. Yes or no? It can be the greater among 2, or it can be the multiple of that greater number, because it has to be divisible by that greater number. Is that clear? This concept, if it is clear, then quick method is very quick. Okay, so let us see now. So if this is then what we'll do, we'll use this information, this knowledge about the LCM, and we'll first assume that the LCM can be 16. It can be 16. That is what we are minimum. It can be the greater number. So is it 16? If it has to be 16, then it has to be divisible by this number. It has to be divisible by this number as well. Then only it is the LCM. It is the LCM. But 16 is not divisible by 12 now. 16 is not divisible by 12. So it has to be its multiple. But which multiple? Now when we did the prime factorization method, you would have remembered that we would have taken the common ones apart, and then I had taken the, see here, 16 was this and 12 was 2 into 2 into 3. This quick method is coming from here only, my dear friends, but with a new concept. So anyways, that LCM has to have this, that LCM has to have all these factors. Only thing that it doesn't have, it should have extra, otherwise it should have extra is this 3 which is we are going to multiply, yes or no. The LCM we had found with the prime factor method, if you remember, it was 2 into 2 into 3 into 2 into 2. So this 2 into 2 and this 2 into 2 has to be there, which is 16, which is 16. Now what is extra here? What was not there in 16? This is how the language we will start to understand. The factor which is not there in 16, we have to multiply with 16. One more time. The factor, the prime factor which is not there in 16, we have to multiply with that number. Then we will get what? We will get the LCM. We have to find out in the bigger number, in the greater number among the two, what factor is missing, which is there in 12. I'll come again. So here, see here, what are the factors of this? We need not have to find the factors, only for your understanding only. These are the factors. What are there already in 12? 12 already 2 into 2 is there. 2 into 2 is already there in 12. Only thing that is not there in 16, which is there in 12, is 3. So I will multiply this with 3. 48. Is it clear or not? If it is not clear, I am going to make it clear, because this is the only method we are going to use now onwards. So I am going to take one more example. Let us take what example? We'll take 9 and 16. 9 and, say for example 14 will take. Okay, 14. So what the first step? Say for example this question I am doing. First step is what? I'll assume this as the LCM. But 9 cannot divide 14, so I cannot take this as LCM. So what I'll do, I'll see what is there in here which is not present here. So what are the factors of this? 7 into 2. Whether 7 is there in 9? No. Whether 2 is there in 9? No. So what are the factors of this? 3 into 3. So what I have to do, I have to multiply this with 9. 14 into 9 will only get my answer. So that is 126 is the LCM. Is that understood? Because 9 is not at all present. All these two factors are not at all present in 14. Therefore, what will happen here? You have to multiply with the 9. Okay. So I am going to remove this, so that we'll do one more question here. One more question. We'll take any random number, say for example 36 and 45. Okay, let it be 45. So I'll take what? 45 as the LCM first. If it is not the LCM, because 36 cannot divide 45, so what I have to see here, what is there in 36? What is there in 36? To find out, I can say it is there 2 into 3 into 3. It will be 18 and into 2. What is there here? Here there is 3 into 3, 9 into 5 is there, right? So 3 into 3 is already present here. 3 into 3 is already present. What is not present here? 2 into 2, which is equal to 4. So I will multiply this with 4 and I will get the answer. 180 is the LCM of this. Can you see the beauty of this method? You have to be able to factorize. You should be able to factorize. Prime factors you should be able to find out. Once you are able to find out the factors of a given number, prime factors of a given number, you will be able to do this method wonderfully. So what I am going to do is, I am not going to give you the numbers. You have to, but take any 20 numbers, 2-digit, we'll do it, 10 2-digit numbers, 10 2-digit numbers and 10 3-digit numbers. You can take whatever. I am not bothered. I want to see the factors of this. I want to see the factors of this. So 2-digit number, like say for example 21, 34, 69 and so on. In 3-digit number 126, whatever comes in your mind, 643. And whenever you are taking, don't take all 100 numbers or all 200 numbers, take it up to 900 as well. So 912 or something. And then try to find their prime factors. It will be a little difficult when you see these number 912 factors. How? So you have to divide it by 2. When you divide it by 2, you will get how much. So it will be very difficult for 4 so 2 will 1 will remain, 5 12, 10 and 6 4 56, and again you have to divide it. 2 2 4, 2 2 4, 2 8 again you have to divide it. This will happen. This will happen, but this is a great practice, my dear friends. You will you will you may scold me now, but you will thank me when you are writing the examination. You will thank me when you write the examination if you do this today. So 220 numbers like this, 10 2-digit numbers, 10 3-digit numbers, and then come back to the next video. Till then you are not going to come back to your next video. Is that clear? Thank you. Let us meet in the next video.